Drop a feather and a bowling ball from the same height, and most people will tell you the bowling ball hits the ground first. It's obvious, right? Heavier things fall faster. That's what your eyes have shown you your entire life. But here's the strange truth. Your eyes have been lying to you. In a vacuum, on the surface of the moon, on a planet stripped of its atmosphere, that feather and that bowling ball will hit the ground at exactly the same instant. Astronaut David Scott proved it on Apollo 15 in 1971, dropping a hammer and a falcon feather on the lunar surface. They fell together. They landed together. And yet, even after watching that footage, something in your brain still refuses to believe it. That refusal is the beginning of a much bigger problem, because almost everything you think you know about gravity is, at best, a useful approximation, and at worst, completely wrong. In Einstein's deeper picture, gravity is not a force in the ordinary sense. It is not simply something pulling you downward. It is the shape of spacetime itself, guiding how objects move. The Earth isn't actually tugging on you with some invisible rope. And the reason you feel heavy right now, sitting in your chair, has almost nothing to do with what Isaac Newton described 3.5 centuries ago. The real explanation is stranger, more beautiful, and more counterintuitive than any science teacher probably ever told you. So let's start from the beginning, with a falling apple, and end somewhere near the edge of a black hole. Newton's story is famous, maybe too famous. The young man, the orchard, the apple, the sudden flash of insight. Whether or not the apple actually fell on his head, the leap Newton made was genuinely revolutionary. He realized that the same invisible influence pulling the apple toward the ground was also holding the moon in its orbit, one law governing both heaven and earth. Before Newton, those were treated as entirely separate domains. After Newton, the universe became a single unified clockwork. He wrote down a simple equation. Every mass attracts every other mass, with a strength proportional to their masses and inversely proportional to the square of the distance between them. It worked. It predicted the tides. It predicted planetary orbits with terrifying precision. It sent rockets to the moon nearly 3 centuries later, and for over 200 years, physicists thought the puzzle of gravity was solved. But Newton himself was deeply uncomfortable with what he had written down, because his equation said nothing about how gravity worked. How did the sun reach across 93 million miles of empty space and tug on the Earth? What was the rope made of? Newton called this idea of action at a distance so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. He had described gravity, but he hadn't explained it. The mechanism was a black box, and Newton knew it. Enter a clerk in a Swiss patent office. In 1907, Albert Einstein was sitting at his desk, reportedly daydreaming, when a thought struck him so hard he later called it the happiest thought of his life. He imagined a man falling off a roof. During that fall, what would the man feel? Not heaviness, not weight. If he reached into his pocket and pulled out his keys and let them go, they wouldn't drop relative to him. They'd float beside him, falling at exactly the same rate. For those few terrifying seconds, the falling man would experience no gravity at all. He'd feel, for all practical purposes, weightless, just like an astronaut. This is the exact same phenomenon you see when you watch astronauts on the International Space Station drifting through their modules. Most people assume they're floating because they've escaped Earth's gravity. They haven't. At the altitude of the ISS, gravity is still about 90% as strong as it is on the surface. The astronauts aren't beyond gravity's reach. They're falling, constantly, endlessly falling. The space station is in free fall around the Earth, and because it's also moving sideways at 28,000 kilometers per hour, it keeps missing the ground. That's all an orbit really is, falling and missing. Einstein's happy thought was that there's no experiment, no measurement, nothing you could do inside a sealed room to tell the difference between being in free fall in space and being weightless in deep space far from any planet. And conversely, there's no way to tell the difference between standing on Earth and standing inside a rocket accelerating upward at 9.8 meters per second squared in the middle of empty space. Gravity and acceleration, he realized, are the same thing. This is called the equivalence principle, and it became the seed crystal for everything that followed. Now hold on to that, because here's where it gets strange. If gravity and acceleration are indistinguishable, then a beam of light traveling sideways through that accelerating rocket should appear to bend, because while the light is crossing the room, the rocket is speeding up underneath it. From the perspective of someone inside, the light curves downward. But by the equivalence principle, the same thing must happen inside a gravitational field. Light, which has no mass, must still be affected by gravity. Newton's theory had no complete way to explain why massless light should bend near a massive object. Light has no rest mass, so its behavior pushed physics beyond Newton's simple picture. But Einstein's idea made a bold prediction. Gravity should bend light because gravity is not just acting on objects. It is changing the geometry through which light travels. This was tested during a solar eclipse in 1919 by the British astronomer Arthur Eddington. He photographed stars whose light passed close to the sun and compared their apparent positions to where they should have been. The stars appeared shifted, closely matching Einstein's prediction. Newspapers around the world ran headlines declaring that the Newtonian universe had been overthrown. Einstein became, almost overnight, the most famous scientist in history. But what had he actually replaced Newton's universe with? This is the part that almost no one explains properly, and it's the part that changes everything. Einstein's idea is this: gravity is not a force. There is no invisible rope. There is no mysterious action at a distance. What we call gravity is the curvature of space-time itself, and objects moving through curved space-time simply follow the straightest possible path through that curvature. The classic analogy is a stretched rubber sheet with a bowling ball placed in the middle. The sheet sags. Roll a marble nearby and it spirals inward, not because the bowling ball is pulling it, but because the geometry of the surface has been warped. That's a useful image, but it's also a little misleading, because it makes gravity sound like it's about space being curved. The real revelation is that time is curved too. And in fact, for objects moving slowly, like you, like me, like an apple falling off a tree, the curvature of time is far more important than the curvature of space. Let me explain what that actually means, because this is the deepest and most underappreciated insight in all of physics. Imagine you're standing perfectly still. You think you're not moving. But according to relativity, you're always moving through space-time at a constant total rate. If you're stationary in space, then all of your motion is happening through time. You're moving into the future at 1 second per second. Now here's the trick. Near a massive object, time runs slightly slower. A clock on the ground ticks more slowly than a clock on a mountaintop. This isn't a thought experiment. It's been measured countless times with atomic clocks. Time, near the Earth, drips a little more slowly than time far from Earth. So when you're standing on the ground, your head is in a region where time flows slightly faster than the time at your feet. The difference is absurdly small, billionths of a second over a lifetime, but it's real. And here's the punchline. Objects, when left alone, naturally drift toward regions where time runs slower, not because anything is pulling them, but because that's what moving in a straight line through curved space-time actually means. The apple doesn't fall because the Earth grabs it. The apple falls because, in the warped geometry around our planet, the future at the ground is, in a sense, closer than the future up in the branches. Falling is just the apple's most natural path through time. This is why a feather and a bowling ball fall together. In Einstein's view, they are not being pulled in the ordinary sense. They are both following the same curved path through space-time. They're both just following the local geometry, and the geometry doesn't care about mass. It's like two cars driving along the same curved road. The road bends them by the same amount, regardless of what they weigh. Newton's equation worked because, for ordinary objects at ordinary speeds, the curvature of time near Earth produces effects that look almost identical to a pulling force. But it's a description, not a cause. The cause is geometry. Now, you might be thinking, this is all very poetic, but does it matter? Does this distinction actually change anything in the real world? Yes, profoundly. Every time you use GPS, you are relying on Einstein's curved space-time being correct, not Newton's force. The satellites that triangulate your position orbit at about 20,000 kilometers up, where Earth's gravitational field is weaker, and time therefore runs slightly faster than it does on the ground. Faster by about 45 microseconds per day. They're also moving fast, which through special relativity makes their clocks run slower by about 7 microseconds per day. The net effect is that satellite clocks gain about 38 microseconds every day compared to clocks on Earth. If engineers didn't correct for this, your GPS would drift by about 10 kilometers per day. Within hours, your phone's map would be useless. The fact that GPS works at all is daily, ongoing proof that gravity bends time. And once you accept that gravity is the curvature of space-time, the universe starts opening up in genuinely disturbing ways. Push the curvature far enough and you get black holes, regions where time slows so dramatically that, from the outside, an object falling in appears to freeze at the edge, red-shifted into invisibility, while, from its own perspective, it falls through into a region where the roles of space and time literally swap. Inside the event horizon, moving forward in time means moving toward the singularity, just as inevitably as you currently move toward tomorrow. There is no escape, not because something is pulling too hard, but because every possible future leads inward. That's not a force. That's geometry as destiny, and it gets stranger still. Because if gravity is the warping of space-time, then disturbances in that warping should propagate as waves, ripples in the fabric itself. Einstein predicted them in 1916, and for 100 years they remained just an equation on a page. Then, in 2015, the LIGO detectors caught a signal, two black holes colliding more than 1 billion light-years away, and the shockwave of that collision shook the entire universe so gently that, by the time it reached Earth, it stretched space by a fraction of the width of a proton. We heard the universe ring. We literally felt space-time flex. So the next time you drop your phone and watch it fall, try to see what is really happening. In the deeper relativistic picture, your phone is not being pulled by an invisible rope. The Earth is not reaching up and grabbing it. The phone is simply following the most natural path it can through a region of space-time gently warped by the planet beneath it, and you, sitting still, are not truly motionless either. Your body wants to follow that same path. But the floor, the chair, and the ground are constantly pushing back, stopping you from falling freely. That solid feeling of weight pressing through your body is not gravity tugging on you in the simple way you were taught. It is the ground refusing to let you fall. Gravity, properly understood, is not just a pull. It is the shape of reality itself. And you have been moving through that shape your entire life, without ever realizing that the ground was the only thing stopping you.